Imagine what you'd see if you had a lens the size of a galaxy. Well, believe it or not, galaxies themselves can actually act as lenses. Astronomers all over the world have been scratching their heads as the James Webb Space Telescope detects 6 new galaxies that should not exist. With a telescope, astronomers and scientists can literally go back in time and see how galaxies were formed over billions of years. But no one was prepared for what they saw recently. 6 previously undiscovered galaxies that threaten to destroy established cosmological theories and ideas. Scientists have declared that these discoveries are technically not supposed to exist, defying established laws of science. What are these new galaxies? How did the James Webb Space Telescope find them? And what are the implications of these discoveries? Join us in this video as we show how the James Webb Telescope detected a structure that should not exist. The study of the universe on its grandest scales, which is the realm of cosmology, is an exciting and ever-expanding field of inquiry. As our technology advances, so does our ability to probe the depths of space, revealing new and awe-inspiring wonders. At the forefront of this cosmic exploration stands the James Webb Space Telescope, named after the astronomer James E. Webb. It is the largest and most powerful space telescope ever built. Its primary mirror, a gigantic structure measuring 6.5 meters in diameter, comprises 18 hexagonal segments that unfold like an origami flower. This immense mirror, combined with its advanced infrared sensors, allows the James Webb Space Telescope to look back in time to the very beginnings of the universe. It captures light from the first galaxies that emerged just 250 million years after the Big Bang. The James Webb Space Telescope's mission seeks to transform our understanding of the universe. It aims to unravel the mysteries of the universe's formation, shedding light on the birth of stars and galaxies, the evolution of cosmic structures, and the presence of potential habitable exoplanets. By observing distant objects that emit light in the infrared spectrum, the James Webb Space Telescope can penetrate dust clouds that obscure visible light, revealing hidden depths of the cosmos. The discovery of new galaxies holds immense significance in the realm of cosmology. Each newfound galaxy represents a piece of the cosmic puzzle, providing clues about the universe's composition and evolution. By studying these distant galaxies, astronomers can gain insights into the formation of stars and planets, the distribution of dark matter and dark energy, and the overall structure of the universe. The James Webb Space Telescope's ability to detect faint, distant galaxies has already yielded groundbreaking discoveries. In July 2022, the telescope captured images of galaxies that existed just 620 million years after the Big Bang, the farthest galaxies ever observed. These observations push our understanding of the early universe to new frontiers, revealing the first galaxies that emerged from the primordial chaos. But what makes this telescope special and amazing? The James Webb Space Telescope is the largest and most powerful space telescope ever built. It is an infrared telescope, meaning that it is designed to detect light in the infrared portion of the electromagnetic spectrum. The James Webb Space Telescope's primary mirror is 6.5 meters in diameter, 3 times larger than the Hubble Space Telescope's mirror. This means the JWST can collect 4 times as much light as Hubble, allowing it to see fainter and more distant objects. The James Webb Space Telescope is also much colder than Hubble. This colder temperature allows its infrared detectors to operate more efficiently, making them more sensitive to faint infrared light. Hubble operates at about -123 degrees Celsius, while the James Webb Space Telescope operates at -218 degrees Celsius. The James Webb Space Telescope also has 4 scientific instruments, each of which is designed to study a different aspect of the universe. These instruments include 1. The near-infrared camera, the flagship instrument designed to take images of the universe in the near-infrared spectrum, used to study a wide variety of objects including stars, planets, galaxies, and nebulae. 2. The near-infrared spectrograph, a spectrograph used to study the spectra of objects in the near-infrared spectrum, allowing astronomers to measure the chemical composition of objects and study their motions. 3. The mid-infrared instrument, designed to take images of the universe in the mid-infrared spectrum, used to study specific objects such as dust clouds and stars in the early stages of formation. 4. The fine guidance sensor and near-infrared imager and slitless spectrograph, a combination of two instruments where the fine guidance sensor keeps the James Webb Space Telescope pointed accurately at its targets and the slitless spectrograph takes images and spectra of objects in the near-infrared spectrum. The James Webb Space Telescope is also a significant upgrade over the Hubble Space Telescope, allowing it to study a different part of the electromagnetic spectrum than Hubble. Hubble is an optical telescope designed to detect light in the visible portion of the electromagnetic spectrum, while the James Webb Space Telescope is an infrared telescope designed to detect light in the infrared portion of the electromagnetic spectrum. As part of its mission to look back in time and observe the origin, nature, and formation of galaxies and search for exoplanets, the James Webb Space Telescope has recently discovered 6 new galaxies. These newly discovered galaxies have captivated the attention of astronomers worldwide, offering astonishing glimpses into the earliest days of our universe. These galaxies, described in a new study based on Webb's first data release, are so far away that they appear only as tiny reddish dots to the powerful telescope. By analyzing the light emitted by these galaxies, astronomers established that they were viewing them in our universe's infancy, only 500 to 700 million years after the Big Bang. Such early galaxies are not in themselves surprising. Astronomers expected that the first star clusters sprung up shortly after the universe emerged from the period generally referred to as the Dark Ages, about the first 400 million years of its existence, when only a thick fog of hydrogen atoms permeated space. But the galaxies found in James Webb images appeared shockingly big, and their stars were too old. According to experts, the new findings conflict with existing ideas of how the universe looked and evolved in its early years and don't match earlier observations made by Webb's less powerful predecessor, the Hubble Space Telescope. In the words of Joel Leha, assistant professor of astronomy and astrophysics at Penn State and one of the authors of the study, we had specific expectations for the type of galaxies that live in the early universe. They are young and small. Previous studies of the early universe with Hubble and other instruments tend to find small, blue baby galaxies, objects which have just recently formed out of the primordial cosmic soup and are themselves building their early stars and structures. In general, young stars shine bright blue as they age. These stars develop a redder glow as they burn through their fuel and cool down. But in the ancient galaxies that Webb was built to spot, astronomers had not expected to see old, red stars. They also had not expected to find galaxies more massive than perhaps a billion suns. But those reddish dots revealed in Webb's deep fields appear 50 times more massive than that. The most massive galaxies in our sample are expected to have masses 2 to 4 times lower than that of our own Milky Way. Scientists were shocked to find out that some of these galaxy candidates are as massive as our own galaxy when the universe was 3% of its current age. Leha said, "Before astronomers start rewriting cosmology theories to explain how these galaxies came together so quickly after the Big Bang, they will have to ensure the odd red dots they're looking at are not something else. Most of the alternative explanations, however, also require entirely new concepts," Leha said. For example, stars in the early universe might emit light in exotic ways due to their lack of heavy elements and perhaps we're not incorporating those in our models. Or, alternatively, perhaps our understanding of how stars form locally, for example, how many stars form from gas as a function of the mass of the stars, is totally inapplicable in the early universe. These things would also be exciting to discover and would also overturn our understanding of star formation in the early universe just in a very different way. He added, "The most important thing is that spectra give very precise distances to these objects," said Leha. According to the study, the distance and the identity of these objects is correlated. If we know the distance, we can pin down the identity and vice versa. So, a spectrum will pretty immediately tell us if our hypotheses are correct. These discoveries are as amazing as they come. To have scientists already challenged to rewrite their theories about the early universe just a little over 6 months after the Webb team released the first observations from the Grand Observatory is unthinkable, Leha said. That while the objects so far do appear to be galaxies, there is a real possibility that some of the entities they found could be supermassive black holes. Black holes are areas in space where a large amount of matter is packed into an area millions of times as massive as the Sun, and when NASA says gravity is so strong that nothing, not even light, can escape. But even if it turns out that some of the 6 objects they found are black holes, it still shows an astounding change, according to experts. Regardless of subsequent reporting, The amount of mass discovered shows that the known mass in stars at this period of our universe is up to 100 times greater than scientists had previously thought. The idea that massive galaxy formation began extremely early in the history of the universe upends what many astronomers had thought was settled science. According to the study, they have been informally calling these objects universe breakers, and they have been living up to their names. In a later statement made at Penn University, Leha said, "We looked into the very early universe for the first time and had no idea what we were going to find. It turns out we found something so unexpected it actually creates problems for science." It calls the whole picture of early galaxy formation into question. One of the lead researchers on the James Webb program, Erica Nelson, an assistant professor of astrophysics at the University of Colorado Boulder, said the researchers were finding impossibly massive galaxies. "These things are gigantic," she said. "We were finding galaxy candidates as massive as our Milky Way when the universe was 3% of its current age." "That was astonishing," Nelson said. "The galaxies they saw were way more massive than anyone expected." According to NASA, Webb's longer wavelength coverage and greater sensitivity will allow astronomers to see closer to the beginning of time and hunt for the unobserved formation of the first galaxies, as well as to look inside dust clouds where stars and planetary systems are forming today. By detecting galaxies in the infrared spectrum, Webb will show us the young universe when the first galaxies formed. Webb's near-infrared spectrograph will also be able to study the spectra of faint and distant galaxies to understand their properties. This includes using Webb's advanced infrared sensors to look through the dust and gas clouds that shroud star-forming regions, providing a clearer view of the processes that shape the universe. One of the most critical questions the James Webb Space Telescope seeks to answer is how and when the first galaxies formed. These primordial galaxies are thought to have emerged from the cooling gas clouds that collapsed under their gravity, giving birth to the first stars. Webb will be able to detect the light from these early galaxies and study their properties, including their size, shape, and composition. By observing these galaxies, scientists hope to learn more about the conditions that existed in the early universe and the processes that led to the formation of galaxies. Imagine having a lens as vast as a galaxy. Fascinatingly, galaxies themselves can function as such lenses. Astronomers worldwide are astounded by the James Webb Space Telescope's detection of 6 new galaxies that defy the laws of cosmology. With this powerful tool, scientists can peer billions of years into the past to witness galaxy formation. But the latest discoveries have stunned everyone. 6 newly found galaxies that challenge established scientific theories. These galaxies, according to scientists, shouldn't exist under known laws of physics. So what are these galaxies? How did the James Webb Space Telescope uncover them? And what are the implications? Stay with us as we delve into how the James Webb Telescope identified structures that defy the known universe. The exploration of the universe on its grandest scale, cosmology, is an exhilarating and ever-evolving field. With each technological advancement, our capacity to explore space's vastness grows, revealing new and awe-inspiring phenomena. Leading this cosmic journey is the James Webb Space Telescope, named after astronomer James E. Webb. This telescope is the most powerful and largest space telescope ever constructed. Its primary mirror, a colossal structure measuring 6.5 meters in diameter, consists of 18 hexagonal segments that unfold like an intricate origami design. This enormous mirror, combined with cutting-edge infrared sensors, enables the James Webb Space Telescope to look back to the universe's very beginnings, capturing light from the first galaxies that emerged just 250 million years after the Big Bang. The mission of the James Webb Space Telescope is to revolutionize our understanding of the universe. It aims to uncover the mysteries of the universe's formation, shedding light on the birth of stars and galaxies, the evolution of cosmic structures, and the potential for habitable exoplanets. By observing distant objects emitting light in the infrared spectrum, the telescope can penetrate dust clouds that block visible light, revealing hidden aspects of the cosmos. Discovering new galaxies is a significant milestone in cosmology. Each new galaxy is a critical piece of the cosmic puzzle, providing insights into the universe's composition and evolution. By studying these distant galaxies, astronomers can learn about star and planet formation, the distribution of dark matter and dark energy, and the universe's overall structure. The James Webb Space Telescope's capacity to detect faint, distant galaxies has already led to groundbreaking discoveries. In July 2022, it captured images of galaxies that existed just 620 million years after the Big Bang, the farthest galaxies ever observed. These observations push the boundaries of our understanding of the early universe, revealing the first galaxies that emerged from the primordial chaos. So what makes the James Webb Space Telescope so remarkable? It is the largest and most powerful space telescope ever built. It is an infrared telescope, meaning that it is designed to detect light in the infrared portion of the electromagnetic spectrum. The James Webb Space Telescope's primary mirror is 6.5 meters in diameter, 3 times larger than the Hubble Space Telescope's mirror. This means the JWST can collect 4 times as much light as Hubble, allowing it to see fainter and more distant objects. The James Webb Space Telescope is also much colder than Hubble. This colder temperature allows its infrared detectors to operate more efficiently, making them more sensitive to faint infrared light. Hubble operates at about -123 degrees Celsius, while the James Webb Space Telescope operates at -218 degrees Celsius. The James Webb Space Telescope also has 4 scientific instruments, each of which is designed to study a different aspect of the universe. These instruments include 1. The near-infrared camera, the flagship instrument designed to take images of the universe in the near-infrared spectrum, used to study a wide variety of objects including stars, planets, galaxies, and nebulae. 2. The near-infrared spectrograph, a spectrograph used to study the spectra of objects in the near-infrared spectrum, allowing astronomers to measure the chemical composition of objects and study their motions. 3. The mid-infrared instrument, designed to take images of the universe in the mid-infrared spectrum, used to study specific objects such as dust clouds and stars in the early stages of formation. 4. The fine guidance sensor and near-infrared imager and slitless spectrograph, a combination of 2 instruments where the fine guidance sensor keeps the James Webb Space Telescope pointed accurately at its targets and the slitless spectrograph takes images and spectra of objects in the near-infrared spectrum.